400 feet of fencing is used to divide a rectangular area into 4 equal regions. Express the combined area of the 4 regions as a function of x. Now, before we even get to that part, let's go over here and let's actually model what we're reading up above. So I'm going to say that the width of one of the smaller rectangles is x. So anything else that is that same width receives an x. And I'm going to say one of the 4 small rectangles has a length of y. So y, and y. Now there's 400 feet of fencing that's used to enclose these 4 equal regions. So let's go ahead and add. How many x's do we see? There's 6 x's. So 6 x's plus 1, 2, 3, 4, 5, 6, just making sure that's correct. And we also have 6 y's. Plus 6 y's is equal to 400. And now I'm going to go ahead and I know that when I construct an equation or a function that represents the area of the 4 regions, it only wants me to use the variable x. And so what I'm going to do is I'm going to start by solving or isolating the y. So I'm going to subtract 6x to the opposite side, and I have 6y equals 400, subtract 6x. Now divide by 6, and I have y equals 400 over 6 minus 6 over 6x. So the 6 needs to be shared with the 400 and also with the 6. Okay, let's reduce this one more time. So I know that 400 and 6 are both divisible, they're even, so if I divide 400 by 2, because it's even, I get 200, and if I divide 6 by 2, I get 3. And 6 divided by 6 is the same as 1. So I just took this equation, and all I did is I reduced it. Y equals 200 over 3, subtract 1x. That's what y equals. So let's go back to this first part. There's more than one way to correctly do this, but I'm going to choose to do the area of just one of the smaller rectangles, and then I know there's 4 like it. So the important thing is you do have to have a function that's created that represents area. So a of x equals. Now I know there's 4 of these small equal rectangles, and each one I am able to achieve the area by taking the width times the length. So the width is x, and before I put down a y for the length, remember we only want to write this function in terms of x. So instead of writing y, I'm going to write what y is equivalent to, which is 200 over 3 subtract 1x, or subtract x. That's how I'm going to represent the combined area of the 4 regions. Let's go on to number 2. Find the domain. Now, unfortunately, I forgot to bring home a calculator again, but this time instead of trying to use Desmos, which does work, but it doesn't equate to what you're doing on a calculator, I'm going to try to use a TI simulator on the calculator. So bear with me. Let's see if this works. So I'm going to leave this up here, and I'm going to jump over to the screen. And I will drop this in case you have forgot your calculator, you're somewhere you want to study, you can use this on your phone as well. Okay, so for this, let's see if I am able to bring this out here so we all can see that screen. I'm going to go up to y equals, and I'm going to plug this in. So it's 4 times x, and then in parentheses, it was 200 divided by 3, subtract 1x. That 200 divided by 3 needs to have its own parentheses, and then subtract 1x, or subtract x. Okay, so this is what I have, and we're talking about the area here, and so I'm just going to do a quick estimation. I'm going to start by saying I know the area is not going to be negative, and I'm going to try going out to, just taking a guess here, I'm going to try going out to 50. I can adjust that if I need to. And then I'm going to do zoom fit. Let's see what this looks like. Okay, so we can see 50 is not far enough. Let me bring this back here, and I'm going to try going out right now to, let's just taking a guess here. I'm going to try 85 and do a zoom fit. Okay, that looks just fine to me. Now, this next question says, what is the domain? So I need to know, it goes from 0 to what? I need to know that exact point right there. So in order to do that, we're going to find that 0. Second, trace. I'm going to go down to 0, and I'm going to go somewhere to the left, anywhere to the left, pressing enter on your calculator, and then anywhere to the right, pressing enter, and then back to that point and enter. Okay, so we have we have a domain that goes from 0 to 66.6 repeating. So I'm going to come up here and we're on to this slide. Give me 1 second to do that. And so how would I correctly write that? X is going like this and repeating. We do want to be exact, okay? We want to be exact. And this is all in terms of feet. Let's write now number 3. Find the area when the length of one rectangle. Okay, the length. Remember, this was the length. So keep this in mind. All right, let's look at number 3 before we talk about the maximum area. Maximum area is going to be a little bit easier. We have that graphing calculator. Right now, we are told that we want to know what is the area of the 4 combined small rectangles when we know the length of one rectangle is 10. So we know this is 10. Let's go back to what we have. We know this is 10, and we know this is the formula I have. So 4 times x times y, but we replace the y with what's equivalent to, which is 200 over 3, and I gotta think, was it minus 1x? And this is what we've graphed. This is what we've graphed. Now, we're told that one of these lengths is 10. So this right here is going to be 10 right here, 10 right here, and so on, right? So what do we know? We also know that y is equal to 200 over 3 minus 1x. Well, here's what I think we can do. I think that if we know that y equals 10, let's replace y with 10. So I have 200 over 3, subtract 1x. I'm going to start by taking 10, and let's move this to the opposite side. Now I have a graphing calculator, so I don't need to worry about combining fractions right now. And then once I get this answer, I'm going to divide it by -1, which just changes the sign. And then I will know what the x value is. So what this tells me is, hey, on this particular rectangle, when this is 10, whatever answer I'll get, I'll know what the x is. So I know the y is 10, but when y is 10, what is x? So I'm going to right now, I'm going to grab that calculator and I'm going to figure out what 10 subtract 200 over 3 is, and then I'll divide it by -1. So I'm going to come right back over to this screen. Let me find it. And I want to clear out of here for just a second. And I want to take 10, subtract, and in parentheses, I have 200 divided by 3. And remember, after I get an answer, I'm going to divide it by -1. Okay, so this is what I have. Divided by -1, I get 56.6 repeating. Okay, so let me come back to this screen, our current screen here. And this tells me that x is 56.6 repeating. Now that's the case when y equals 10. So how is that helping me? I'm going to go back to this equation that I plugged into my calculator, and it produced this parabola that looks like this. And I'm going to figure out when x is 56.6 repeating, what is the area? So coming back to this calculator, let's graph what we have, and now let's figure out second trace. Let's figure out the value when x is 56.6 repeating. So I'm just going to go 6, 6, 6, 6, 6, 6, 6, 6, 6. And what does it match up with? It matches up with 2,266.6 repeating. That's the area. The units are feet, so it's square feet. 2,266.6 repeating square feet. The next question, which is question number 4, says what is the maximum area? So to figure out that, I want to know what is this highest y value. Remember, x is the smaller width of one of the 4 equal rectangles, and your y value is what is the total area of the combined 4 rectangles. So second trace, I want to know what is the maximum, which is 4. I can go anywhere to the left, so I'm going to just type in a number that I know is to the left. There we go, that's 15. And then, oops, that's a little bit too far to the left. Let's try this again. Second trace, maximum. We'll go anywhere to the left of the highest point, and I'll press enter. Then anywhere to the right of the highest point, again, I'll press enter, and then back to the highest point. And there we have. So what does this tell me? Down below, I look at that x and y, what does this tell me? It tells me the maximum area of this shape, given the information of having 400 feet of the fencing would be 4,444.4 repeating. That's the maximum area. That occurs when the width of one of the smaller rectangles is 33.3. So if I can come back up here, the maximum area will be achieved when this length of one of the four rectangles is 33.3 repeating feet. Let's go on to the next one. What is the dimensions? Well, the dimensions is a smaller one, so they're saying one of these. Well, we just know this is already going to be 33.3 repeating. That's going to be the width. Now, how do I figure out what the length is? Well, we have that equation, y equals 200 over 3 subtract 1x. And we know x is 33.3 repeating, so let's grab the calculator. So coming back here, I'm going to clear out, and I'm going to start with 200 divided by 3, make sure it's in parentheses, subtract 1 times 33.3 repeating. And we can see the length of one of the smaller is, it happens to be the same, is 33.3 repeating. That's not always going to be the case that they're exactly the same. Whoops, so sorry here. Meant to do, here we go. So this is also 33.3 repeating. All right, let's see. And that happens to be our last question, is number 5. Hopefully that helped you today.